Hello, this is video J, and in video J, first of all, I'm going to try to make this one a lot shorter to make up for the last one, which was really, really long, but hey, we turn conditions every which way but loose, so if you watch that and you digested all of that, then you're an expert on conditions. Let's make them useful. Using conditions. There are special statements in C++ that only exist because they make use of conditions and do things in our programs that we like. That was an empty, useless statement, and I'm sorry I said it, but I don't want to start the video over. An if statement, STMT is my abbreviation for statement. If statement format has a reserved word if. Can't use that as variable name. It's a reserved word, if, and then in parentheses, some condition, which I'll use my pointy bracket conventional notation, close curly bracket, and then a group of statements in closing curly brackets, also known as a statement block, STMTBLK. But we're going to possibly have more than one statement block, so I'm going to distinguish this one as statement block capital T. There. And if you're wondering, where are the curly brackets? They're built in. Statement block, by definition, is a chunk of statements, a group of statements, a sequence of statements enclosed in curly brackets. Now, I said we might need another statement block. That's optional. We might have an else, ELSE, also a reserved word in C++, and a statement block, STMTBLK. But this one's statement block false. And I'm going to switch colors and put just, I guess, brackets around that. That's not part of C++. I'm going to label this as optional. We might have an if without an else, is what I mean to indicate there. What's the effect of this? The effect is, if condition is true, pointy brackets condition, the one that's inside parentheses, if condition is true, then statement block T is executed. Well, it could be simpler. STMTBLK. You know what I'm trying to write. Statement block true is executed. By whom? Well, by the CPU. I mean, this is as the program's running. When the program's running, one statement after another, assignment statements, variable definitions, and so forth, and gets to the if, it will stop at the if, see if the condition is true. If the condition is true, that we put inside parentheses, then it will execute all the statements following that are enclosed in curly brackets. The statement block true. Statement block true is executed. Otherwise, comma, there's no testing of another condition. You don't need another condition to get the opposite of this. It's built in automatically if you have an else. Otherwise, statement block F is executed, STMTBLK, capital F, the false statements, is executed. And since that's optional, I'll say if present. Now, I filled up the whole board, and all we did was look at this one statement. The if format in C++, just about every language, actually, I'll go on a limb and say every language has some sort of if conditional facility. Here's what it looks like in C++. If, and then in parentheses a condition, if that condition's true. Now, it's usually going to depend on variables and so forth, so it might be true one time you get to it in a program, but it's not necessarily always going to be true. But when we get this far, it'll test the condition. If the condition is true, it does the statement block T. If the condition is false, no additional test needed, it will drop down and do the else. Now, woven into that, if you're reading between the lines or hearing between the lines, is if both statement block T and both statement block F, if those two statement blocks are both present, there's no way to skip both of them. When you get this far, the condition has to be true or false. There's no gray area. If it's true, it does statement block T. Otherwise, it does statement block F. It's what we in the biz would call an exclusive OR. It's got to do one or the other. It can't skip both of them. It can't execute both of them. Okay? Now, I don't really have room for an elaborate example, but that's fine with me. And in an effort to keep this video short, I'm just going to do some formats and effects, and then I'm going to do whip up an example on the computer, and the next video will be a session where there are examples of this. So get all this down so that you can refer to this in your notes when you're watching the example, the coding example. And this one's going away. There goes the if. Another way to use conditions is a while loop. W-H-I-L-E-L-O-O-P. The format for a while loop. The keyword while, reserved word while. Also a condition in parentheses. Close parentheses. And also a statement block. And I'm not going to label this one true or false. I'm just going to call it statement block. S-T-M-T-B-L-K. Indented because we indent by convention. It's not required in C++, but we're going to indent all of those statements that are inside the statement block so it's visually clear to whoever reads our source code that that's only going to be executed as part of this while loop and only if that condition is true. The effect of this. When control reaches the while statement, 1. Condition is evaluated, again, by the CPU. 2. I'll put dots. I mean, this is probably not the beginning of our program. We read its various variables, maybe did some calculations, whatever. But when we get this far, when it hits the while statement, condition is evaluated by the CPU. If true, then I'm going to indent my steps over here. If it's true, 2A, statement block is executed. S-T-M-T-B-L-K is executed by the CPU. 2B, control, in other words, the attention of the CPU, control returns to step 1. There's no else with a while. A while loop is when you want to do statements over and over and over again. As opposed to, I'm going to use a student misnomer. Don't say this to me ever. An if loop. Ain't no such thing. There is no if loop. If is a one-way trip. When you get to an if statement, either you do it or you don't, but you don't even look in the rearview mirror. You just keep going. A while loop, if you get this far and the condition is true, then initially it behaves a lot like an if statement. It will execute the statement block that's beneath it. The big difference is after it finishes executing the statement block, it goes back up and evaluates the condition again, possibly going around and around and around in a circle. 3, I'll put in parentheses because there is no test, there is no else or anything if condition is false. Then control picks up with the statement after the statement block. Control goes to, CPU control goes to next statement after, A-F-T-E-R, statement block. Insider slang for that is it falls out of the loop. Falls out of the loop. Now, let me read this back just to get my mind around all this. We're looking at a while loop. It's got to have the reserved word while. It's got to have the parentheses, not optional. And notice there is no semicolon at the end of this. Unfortunately, again, just like using an assignment statement for a condition, it is not syntactically incorrect to put a semicolon right here. You know what happens when you do that? That means that this is your entire while loop right there, and it just sits and spins if the condition is true. While x is 0. If x is 0, double equals 0, then that while loop will execute forever. An infinite loop, which is bad. You don't want that. You want it to keep going. You want it to eventually execute the rest of your program. So here, do not put a semicolon. You'll see that in the examples when we look at examples of whiles and ifs and so forth. So that's not something you have to memorize. You just look at the examples very carefully. Okay, if the condition is true, it does the statement block. After that, here is actually the biggest. That gets a little green star here. This is the biggest difference between a while and an if, aside from not having an else. Control returns to step 1. It goes back up and does the condition again, possibly going through several times. Okay? Now, I didn't leave room to write again, but I'm going to say this very carefully and try not to go too quickly. What if we get this far and the condition is not true? Then it just skips all this and falls out of the loop. In other words, it behaves exactly like an if statement that doesn't have an else. If we get here and the condition is false the first time, it completely skips over the statement block and doesn't execute it at all. That's not a horribly big deal. Here's the horribly big deal. If we get this far and the condition is true, there must be some way for that condition to eventually become false by executing the statement block. That was a mouthful, wasn't it? I'll repeat it. If we get this far, condition is true, there must be some way for the condition to become false as the result of executing the statement block. Otherwise, again, we've got an infinite loop, and nobody wants an infinite loop. That just means the computer just sits there, doesn't get any further at all. Okay. Now what? What else we got? Well, there's still another way to use conditions. It'd be easier to do this with both hands. One of my goals for summer school is to perfect my border racing technique. I certainly don't have it mastered yet, but I do know it's going to involve both hands. A for loop, F-O-R loop. The format for a for loop. Okay, take a deep breath, think pleasant thoughts. The for loop looks really weird in C++. Let me prove it to you. The format is the word for, of course it is, no big deal. Open parenthesis, then a statement that's called the initialization statement, init for short. Pointy brackets, and I'm still inside the parentheses, then a semicolon. Then a condition, C-O-N-D, close pointy bracket, but still no parentheses. Wait, there's more. Another semicolon. Then a third statement called the increment, I-N-C-R. Finally, mercifully, not only do we close off the pointy brackets, we close off the parentheses. And indented beneath that inside curly brackets is statement block. I warned you, that one is weird. The effect of this. The effect of this. Init. Now, this is again. If we get this far in the program, and now we've reached this from above, this is the next line to execute. Here's what the CPU will do. Init is executed by the CPU, of course. I'm going to stop saying that. It's executed. Init is executed unconditionally. C-O-N-D-I-T-I-O-N-A-L-L-Y. Emphasis on the un. Unconditionally, comma, one time. Init is executed unconditionally one time. Isn't that weird? We get here, and clearly we're trying to start a loop, but it doesn't even look at the condition yet to see whether or not we're going to loop. It goes ahead and does the init statement anyway. unconditionally without checking anything. Then a statement that I'm going to label top, since I'm not using numbers in this effect. Top is the next statement. If condition is true, then statement block is executed. That EXEC''D, you see that several times all over the place. That means executed. That's my abbreviation for executed. Oh, but wait, there's more. Even though it looks like we've done everything there is to do here, we haven't. Here is the weirdest part. This could be the weirdest part of the weirdest statement in C++, for all I know. The increment is executed almost as an afterthought after the statement block has been executed. So it's as if we slip in whatever this increment statement is, we slip that into the bottom of the statement block's curly brackets, and it's done down here, rather than way up there when the CPU first gets to this for statement. Weirdness, weirdness, weirdness. And then I'll put in parentheses, control returns. It just means the CPU goes back. Control returns to top. That's why I labeled that statement. Control returns to top. So it goes back through, and of course, if the condition is not true, then falls out of the loop. There is no else for a for, just like there is no else for a while. The only one that gets an else is the if statement. Now, this one, let's take a second look. Init is executed unconditionally by the CPU when we get here exactly one time. It's not even in the loop. It's pre the loop. It's before the loop. It's to initialize things that we need to initialize before we even start the loop. Then, after that statement's been executed, the next thing that happens is this condition is evaluated by the computer. Is the condition true? Let's say it is. Yes! Then it executes statement block, the whole thing. Now here's where it differs from a while loop. After it does the statement block, does it go back up and do the condition again? Not yet. After it does the statement block, which could be 10 statements, 20 statements, who cares? After all of those are done, after every single statement in the statement block is done, then the computer executes this increment statement, way back up here at the top of the for loop. Weirdness. Weirdness abounds. After it does the increment statement, then it goes back and reevaluates the condition. Man, an example might clear that up, or at least I hope it does. And that's such an ugly effect. No, it's not really. But I need that board space, so I'm going to erase this. And the longest note, possibly the longest single note I've written so far, after a bold line. Note, this is exactly, ACTLY, equivalent to this. Here we come again. I'm going to make up a new format. Everything is so abstract. Don't worry, we'll have concrete examples in the next video. Init. It executes the init statement. Then I'm going to use while instead of for. While parentheses condition. While parentheses condition, it's going to execute the statement block if that condition is true. I'll indent that, STNTBLK. But wait, there's more. After it's done the statement block, then it does the increment statement. This, the green loop in for, with for, is exactly equivalent to this while loop. Look how this operates. Execute, execute, execute. Then it gets down here and does the init without even looking forward, without testing the condition or anything. Then, after it does the init, it checks the condition. If the condition is true, it executes the statement block. After it's finished with all the statements in the statement block, then it does the increment statement. And since we're at the bottom of the while loop, it goes back up and checks the condition again. Now, if you compare that to the effect I just erased, it is identical. How exactly equivalent is it? Well, by the time your program's translated in the machine code, the CPU doesn't know whether you type this in your source code or you type that. They turn into exactly the same machine code. And I'll suggest that is pretty exactly equivalent. Which begs the question, why have a for loop anyway? For loops are in love with arrays, the C++ equivalent of Python lists. An array is where you've got a whole bunch of values stored together inside one variable, air quotes variable. You could view each element in the array as individual variables, but we will see for loops just about every time we see arrays, the lists. Okay? Now, I could say more. I won't. I wanted to keep this video short. You're welcome. And the next one will be examples of all this stuff. So look at this carefully, get it all down in your notes before you go to the next video, and I'll see you online. Bye.